All right. Well, welcome, everybody. Welcome, everybody, and thank you for joining us. We have folks here in the Boston office, as well as live streaming in. My name is Ryan Lynch, Vice President of Shawmut. I'm here to welcome you and to thank Kelly Lyons, our Preservation Director, for pulling this together. She recognized the junction of both Safety Week here at Shawmut and throughout the construction industry, and the fact that it was Preservation Month. And brought together a great team of experts who we'll introduce you to in a few minutes to talk through a great subject around renovation work and the potential hazardous materials that may be encountered. Next slide. At Shawmut, we always open our events with over 12 people with a safety moment. You're going to see on the screen the emergency egress here by Fernando, that way, and then out the back should an emergency arise. I need a volunteer to call 911. Looks like Scott Santry. Thank you, Scott. And a volunteer to do CPR should an emergency arise. And seeing Sean in the back. Thank you, Sean. So with that, we're going to get into our presentation, and I'm happy to introduce Kelly Lyons.
Hey everyone, thank you for coming. So we pulled this event together today just to pull in not only Safety Week, but Preservation Month. And a question we get asked a lot about our jobs is the abatement. It's a hot topic for owners, it's for clients alike. They want to know, there's a lot of questions that we get asked on, what do I look for? What are the hazardous materials, especially in a renovation, in a historic project, based on the age of the building, what do I look for? Also, they want to know what the abatement process is. Some people have seen the abatement containment go up. They want to know what happens underneath the plastic. So we wanted to answer some of these questions. We also wanted to talk about, is it safe to live and work here? We do have some homeowners from the Boston Preservation Alliance on listening that want to know, are their homes safe? Can they still live and can they still work there if there's lead paint or if there's asbestos in their homes? We also wanted to talk about salvaging items. Some people want to just throw everything out. We want to let them know that there are ways to salvage historic items safely and reuse them in their projects again. So the goals of this presentation today are really to empower people to be confident, to know when to call that professional, and to know that abatement can be done safely and it's not as scary as it sounds. So with that, I will introduce the rest of the team. Next slide, please. Okay, so we have everybody's met Ryan Lynch. We also have Sean Cavallo, our Chief Safety Officer here today. And then from the NorthStar team, we have John Ryan, this Regional Health and Safety Manager. We have Andre Barboza. He is the Senior Estimator and Project Manager at NorthStar. And then we have Allison Frazee, the Executive Director from the Boston Preservation Alliance. And with that, I'll hand it over to Allison. Thank you.
Thank you, Kelly. And thank you to Shawmut for having us here this afternoon. We're really glad to be here. This is such an important topic, so we're glad to share this information. So again, I'm Allison Frazee. I'm the Executive Director of the Boston Preservation Alliance. We are a 501c3 nonprofit, so we work very closely with people like Shawmut, also with the city and homeowners and community members. Our motto is protecting places, promoting vibrancy, and preserving character. So traditionally in the historic preservation field, we care a lot about historic character and fabric, and that's why we want to keep buildings around, right? That's why we want to preserve places. Next slide, please. But there's another reason why we want to preserve places as well, and that's for the planet. We preserve buildings, we preserve the planet. There we go. So in the preservation community, we've been using the phrase for quite some time. The greenest building is the one that already exists. You may have heard that before. All of the energy and carbon and materials that went into building that structure are already there. So reusing them is the best thing we can do for the environment. Lately, in more recent years, we've been using the phrase building reuse is climate action. Reusing buildings is one of the best things we can do for climate preparedness. Reusing buildings is also one of the best things we can do for our affordability crisis. Naturally occurring affordable housing exists in our existing and historic buildings. They're typically cheaper to renovate than they are to demolish and build new units in Boston especially. So for many reasons, not just historic character and historic fabric, we advocate for building reuse. Next slide, please. What you'll see here is a little graphic that I share often. And what it says is the average single family home in America, when demolished, creates about the same amount of waste as the average American does in their entire lifetime. So we're not talking about small amounts. We're not talking about straws and plastic bags and cups. When we demolish a building, we're sending a significant amount of waste to a landfill. So again, the best thing we can do collectively for the planet is to reuse the building stock that we already have. Boston is a built-out city. We have a handful of empty lots. We need to be prioritizing reuse of the buildings we already have when at all possible. Next slide, please. I wanted to just mention a few of the partners that we're working with because this conversation has gained a lot of steam in the last few years. It's not just the preservation community. I've been working very closely with the Zero Waste team at the City of Boston's Environment Department. You may know a lot of cities across the country have started deconstruction and salvage policies and programs. We don't have that in Boston, but we have a pilot program to start working with deconstruction and salvage. So if you are working on a building that needs to come down or is going to come down, make sure you reach out to the Environment Department and learn about our deconstruction and salvage options here in Boston. I've also been working with the Mass DEP Deconstruction Working Group and the CLF Boston Reuse Working Group. There's a lot of conversations around circular economy and building reuse, deconstruction, and salvage. Recycling Works in Massachusetts is also working on it and have been part of these conversations. And then I wanted to share All for Reuse. They have a really wonderful ecosystem map where you can find who's doing deconstruction and salvage, companies that will actually come get the materials and make them available, do the abatement as necessary so that they can go right back into other projects. So check out that map when you get a chance. Next slide, please. And then I wanted to share a little bit of contact information about the Alliance. This is one part of the work that we do. So if you'd like to follow along, we have, which will be on the screen in a moment, we're on social media, so you can find us there. You can look us up at our website, bostonpreservation.org. And you can always email me or reach out to me if you'd like to be a part of the work that we're doing. So with that, there we go. And that's all our information. So please do look us up and be a partner in this progress that we're making with preservation and the planet. So I'm going to pass it on to Sean now.
Thank you. All right. Well, as Allison said, if the best way to recycle and to help the planet is to reuse these existing beautiful buildings, what's one thing we have to be concerned with? Health and safety of the folks that occupy today, that will be there through the life of the project, and that will occupy permanently for generations to come. So if we have to worry about that, there's something that we really need to know about in advance. Trying to queue up the slide here. Which is knowing what's inside of the material. We can't walk into a building today and understand what's safe and what's unsafe. We can see if there's a hole in the ground, but underneath this floor, is there asbestos? Is there lead? Is there potentially PCBs? I don't know. To the naked eye, it's very difficult to understand that. We can make some assumptions based on the year of the building itself and with the characteristics of the material. But really what we need to do is have what's called a hazardous materials report completed for that space. That's going to be done by a certified industrial hygienist. They'll come onto the building, they'll rip up that floor, they'll take samples, and they'll take them to an accredited laboratory where they'll analyze these samples for hazards, whatever you ask them to sample for. So that's how we're going to know what is in the space and how to attack and approach the construction phase of the project. This is a sample of what a lab report could look like. And the biggest thing that we like to say here at Shawmut is every one of these has at least a staple or a paper clip. Okay, it's never just one singular piece of paper because we don't know where it came from, what lab it came from, what material was actually analyzed. So you need to have somebody that understands what they're looking for, come out to the job site, sample all of the materials that may be impacted throughout the life of the job, get that to the accredited lab, get a report like this completed, and then sent back to the company that's going to be doing the work, where you can start to engage conversations around how we're going to approach it. Okay? And that's what we have NorthStar here for today. But before we bring NorthStar up, I just want to give a list of different materials we need to be concerned with that could have asbestos or hazardous materials inside of them. Just not reacting. So typical hazardous materials in historic buildings, right? There's an awful lot and a lengthy list here up on the screen. And so ultimately what we need to worry about is everywhere and in everything. Because again, to the example of underneath this wood floor, we truly just don't know. And so before we impact that and potentially, you know, do this type of work around occupied people, around the construction workers on the job site, you know, putting this stuff into the air, we truly need to know what we're working with. Okay, fair enough. All right, let me bring up to the stage Ryan again. Here you go, Ryan.
Thank you, Sean. So up on the screen, you're going to see some examples of some wonderful restorations that we've completed. As Allison said, you know, the greenest building is the one that we're reusing. So all wonderful examples of projects that required the step of identifying, pre-planning, the safe removal, and then the revitalization of these buildings into, you know, fabulous buildings where people are going to live and work and educate for the next 100 years. So some really great examples of clients that truly appreciate what they have in these buildings, and then bringing together a professional team that can take care of those issues in a safe manner. So with that, I'm going to turn it over to John at NorthStar.
Thank you, Ron. Hey, good afternoon, everybody. Talk about hazardous building materials. Well, we're going to talk about asbestos, lead, and PCBs. But everyone should keep in mind, they don't become hazardous unless we impact them, deteriorating, not maintained properly. I think most of us were brought up in homes and gone to schools with asbestos and lead. You know, so as long as it's in good condition, it's usually a pretty good deal with. So asbestos, right? It's naturally occurring. It can be anywhere. Sorry about that. Even in Western Mass, when they were putting the Mass Pike in, they hit a vein of chrysotile asbestos during construction. So anywhere it can be found. Very abundant, right? Last time EPA tracked it, within over 5,000 products. That's a lot of products. Crazy number, all right? But asbestos has these unique properties, right? It's fire resistant, okay? Acid resistant, okay? Its strength, multiple, non-conductive, right? Abundant in the environment. And one thing was the way it's mined, it's very, very inexpensive to manufacture because when they mine it, they break it down so far. These are the 6 big types of asbestos, all right? You have chrysotile, amosite, crucidolite, tremolite, acinolite, and anthrolite. The 3 you'll see in this country basically is chrysotile at 75%, all right? It's put in every product just about. Amosite's at 25%, but you're only going to see amosite really in lab environments. They do a lot of for ceiling tile for explosions, all right? Then you have crucidolite at 5%. Crucidolite sometimes you'll see with chrysotile in a transite pipe mixture, all right? The 2 big things is that people really misjudge or don't understand. You know, you have non-friable and friable asbestos, okay? Friable asbestos, you put it between your fingers, go like this, it pulverizes and you get airborne. That's bad. Then you have non-friable asbestos. That's bound in a matrix, can be asphalt, can be a plastic, like floor tiles, all right? You cannot crush them in your fingers, all right? And many of us have walked over asbestos floor tiles for years, all right? Because they're wear factor. So if they're in good condition, it's safe. Now, here's a whole list of materials. I think, you know, Sean's mentioned some. We could be here for days talking about them. But, you know, wall plasters, ceiling materials, right? TSI, you have gaskets, papers, filtering. And today, they're still utilizing filtering. especially in a lot of chemical manufacturing plants. All right. You see the one up there, asphalt. We didn't realize that we were involved in the Central Artery project that up to 1961, the Federal Highway Administration in their spec called for 1% chrysotile in the binder coat for all roadways. You know, we did all kinds of sampling, didn't find anything, but it was just odd to find that. You know, you never know, it's everywhere. Concrete. We have taken down many hotels, and the cantilever balconies, they were poured separately than the built structure itself. And we have actually seen chrysotile asbestos in the cantilevers to give it that flexibility and strength. Now, like Sean said, you have an unlicensed asbestos inspector come in, do a survey. Now let's say you find something. So now you bring in, you know, a GC, a construction manager, or a contractor. Contracts are done. Now you have to do the notifications. There's 2 notifications in Massachusetts you have to do. You have to notify the DEP, okay? That form is ANF 001. Then also we advise to do the demolition form AQ06. And I'll tell you why. If you have it, you're on a project, you have your notification in play, and you don't do the demolition notification, all of a sudden you rip that wall open as a chase. And that chase is asbestos. Well, the first thing you're going to do is going to try to get an emergency waiver to get it removed. Well, DEP, the first thing they're going to ask is, do you have a demo permit? If you don't, that could push the project back 10 days. So we always advise everybody, we do it on all projects, but everyone should do it, is pull both permits at the same time. All right. Also, they're $100 a piece. There's $35 for revision. Anything is a revision nowadays. You know, the amount, you know, the location, type, anything is a revision. And it's all done online. There's one thing we did put up there, NTWP, non-traditional work plan. That come into play 2014 regulations. And basically, if you cannot remove the asbestos per the regulations in a full containment or one of the methods that are allowed, you would have to get a non-traditional work plan. The thing with that is you have to bring a licensed designer on board. They put a plan together. It's submitted to the DEP, and they have up to 30 days to review it. And right now, this time, DEP is very busy, so it's really running a full 30 days. So if you had that situation and you knew it was coming in the future, you want to plan for it. And I'll give you a prime example. The regulation allows you to remove window caulking with just a drop cloth, a regulated area with men outside and the inside sealed. Now you do 100 windows in a row, I come to a door frame. The regulation does not allow you to remove the caulking around the door frame the same way. You had 2 options. You're going to build a full containment and remove it, or you're going to go for a non-traditional work plan. In a situation like that, it'd be quicker to build a full containment. But if you had, you know, seam joints in a masonry building, you know, vertical going up 10 stories, you would probably really want to get a non-traditional work plan than scaffolding the entire building. But it's just something to think about when you're planning. Now, I want to show you some pictures. You know, we talk about regulated areas. No one really gets a chance to look in there unless you're licensed. So if you look at the first picture, that's a containment built, walls, the negative pressure, and you can see it's a plastic material. The second picture you're looking at, it's completed, blasted, and it's being vacuumed up right now. The third picture is what the exterior looks like. You have 3 chambers. You have a clean room where the crew enters on my right-hand side. And then you have a shower unit, which you see the hoses, you know, hot water heater, manometer, regulating the pressure, and then a dirty room. So that's what you would see from the outside. But now you can see the inside also. What I'm going to invite Andre Barbeau. He worked in this project. It's a very historic project, and he can give you a lot of good details about it.
Good afternoon, everyone. This is another example of some abatement activity that's happening inside a containment. In this particular project, we had to remove the windows from the window frame, and those windows was taken to be restored so they can reuse in the building. So what you see in the first picture was one of the many products that we tried to use in attempt to save the glass, the pane of glass in the window frame, so the painter could take the window sashes to be stripped of the lead paint, so they could repaint the sashes to be reinstalled. On this particular project, we work with Shawmut. We were very successful there. I believe, was over 700 pane of glass, and we save over 85% of them to be reused on the project. So we used 6 different types of chemicals until we found the right product that works the best. Next slide. So on this particular picture here, the interesting that we found as we progress with the removal of the glass pane, one of the window frames, I don't know if everyone can see, it has a date written on that was from November 7, 1645. So that particular window, it's been over 300 years that was salvaged on this product that was reused. This next slide, it was another project that we did in Boston that we had to remove the asbestos caulking and the asbestos glazing. So this particular project, they were having water infiltration. And as you can see in the photos, those were stained glass that we were fortunately that we did not damage them. So they were able to reuse on the project. I'll bring back John to talk about some more regulations and other asbestos materials.
Is it on? Good now? All right. Testing? Here, thank you. I want to go over some dates with you because everyone gets confused. You know, you look at some of the regulations in OSHA, they say 1980, from 1980, okay? But the dates are crazy. If you look at the board, from 1973, the first banned sprayed applied prior proofing, right? You see another date up there, 1978. That was for the popcorn finishes. So there were 2 different bans. You go in 1975, your thermal system insulation. Then look at, we jumped. 1989 flooring felts. 1989 commercial paper and corrugated paper. 1989 new uses of asbestos. That's 1989. We've been dealing with it for many years. So these are the projects that are not banned, right? Asbestos cement products. And when I talk about that, that's your transite pipe, your siding on your homes. You see the older homes, the transite siding, okay? Asbestos friction products. That could be multiple things. That's clutch pads, brake pads, okay? Vinyl asbestos floor tile, still not banned to this day. Non-roof coatings and roofing felt and coatings. But the manufacturers, they're not going to manufacture it just because of the legalities of it. But legally, they could still put them on the market. This shocks me when I look at this. You know, we're talking about 2019. Still in America did not have a full ban on asbestos. All the is in Washington. All right. So 2019, the EPA came up with a final rule, you know, trying to grab it. And basically it was any discontinued products that were taken out of the market cannot be brought back into the market. So now they're really making a big push this year. They're hoping by the end of this year to have chrysotile banned in the United States. But one thing you have to think about, there's 55 countries in the world with a full ban on asbestos. 55. Yeah, the greatest nation in the world still does not. And the group we're in, you get confusing because you have the United States, no ban. The Soviet Union, no ban. China, no ban. India, no ban. There's a couple of more. So hopefully the EPA and everyone gets together. So by, I think it's 1925, they have a full ban on it. But the way they're attacking it, they're getting a little smarter. They always tried to go after products. You should have went after the type of asbestos. And that's what they're doing right now. So hopefully they will be successful. Let's talk about a little lead. All right. Homes, batteries, cables, paint, even your ceramic tile. When I say that to people, they go, how's it in ceramic tile? It's the glazing on the ceramic tile that has the lead in it. So people didn't realize that, all right? Solder, piping, we're all full aware of those. And we have multiple regulations for when it comes to deal with lead. You know, you have the EPA with the lead-based paint pollution prevention program, which basically led to, you know, lead renovation, repair, and painting program, which that means that if anybody's doing work in your home, you know, prior to 1978, they need that training. So they understand how to control the dust, do a clearance, and a visual, right? Then you have DLS. They make the regulations for lead abatement workers, for the training, the procedure for containments and the licensing. Then you have DPH. They handle a lot of, you know, the children, the blood testing. They have their own set of regulations also, but they also handle the licensing of lead inspectors in Massachusetts. So we're talking about saving things, right? We don't want to damage everything. We have so much history that probably got thrown away because people just want to throw it because of asbestos or lead. And that's crazy to me because it's nowadays, there's so many different ways we can save everything. This one, you're looking at a chemical. There's multiple chemicals in the market that do a great job that do not hurt the substrate. Okay, is there one fix for all? No, there's not. It all depends on the substrate and what you're trying to accomplish. So let's talk about the waste. There's some confusion. We see a lot of confusion on that. The EPA many years ago changed the lead law for waste regulation when it comes to residential. If it's residential property, you do not have to go out to a HAZ facility, a TSCA facility, nothing of the sort. That can be going right into your regular waste stream, right? But if you're in a commercial project, you need to test it. It has to be TCLP tested, okay? And what you want to do is, if you're in a large project, once you get the project, get involved in the project, as we do, we send team in and we do the sampling of the waste streams. So we know up front what we're going to be getting into. You don't want to be 8 months into a project in your home or anywhere and find out you have a problem, all right? So we do that ahead of time. So residential, you're good to go. When it comes to commercial, you have to do your required testing. Talk a little about sandblasting. I know they wanted to mention sandblasting. We do get involved in a lot of sandblasting projects. Is it the fix-all? No, it's not. When it comes to sandblasting, a lot depends on it. The substrate. It's the wood. What's the species of the wood? The concrete. You know, what PSI is it? You know, depending on the PSI, we might not be able to get everything off we need to get off. So steel, it depends the age of steel, how porous it is. What's the profile going to be when we're done? So there's many things. It's the same thing with coatings, right? I mean, if you have a lead coating, it comes right off. We've done epoxies in tunnels. That takes you forever to get off. Again, you have to make samples. You mock up the areas. Abrasive, I think I've all been around long enough to know there's multiple abrasives. Everyone leaves a different profile and a finish, okay? You have your black beauty. You have your glass. You know, your slag, garnet. You know, then slurry and wet blasting. This wouldn't be something you'd want to use in your home or a renovation job because the slurry is very hard to control. It all depends on the situation, all right? We can mix it with different percentages of garnet. We've actually used this process in a large project in New York to remove asbestos mastic off the inside of a building, off brick. You know, it worked great, but again, the water becomes a problem, especially. Sponge, we have never done sponge personally. We have been involved in a project, seen a project where sponge was used in a very famous building, and it did a great job. But the only thing is, 8 months after it was done, and the wind blows, a sponge comes falling out of someplace because it gets lodged everywhere. So it does a great job. And then, right, different types of sandblasting, right? Like we were saying, it comes pressure, nozzle size, you know, what type you're going to do, what's the access to the building. You got to worry, you know, some people worry about ventilation. It all depends. We do it inside of buildings all the time. You know, you build a containment, you control it. It's very easily controlled. It depends what type of finish you're looking for. But again, it's not the cure-all. There's multiple ways to do it. This is just a picture showing you on the brick. You know, one to the left is on brick, one to the right, he's doing a piece of steel. It's another one. You look at the picture, you see the coating. on the terracotta and the brick. Look at it after it's blasted. It looks great. And terracotta is very difficult. You know, it wants to fall apart just looking at it sometimes. Wood, these are my favorite ones. You walk into these old factories and warehouses and they got lead paint everywhere and they blast them and look what it looks like. It's beautiful. You know, why would you want to demo something like that? You know, same thing, the wood. That's a better picture. Steel was very well too. You can see the left, pretty rusted piece of steel, and then they're all blasted up. They look like brand new. But the only thing with steel is if you're going to blast it like that, you better be prepared to coat it immediately because it can rust over quickly, especially in the weather we have. You know, you could blast it today, you go back tomorrow afternoon, and you got rust, and then you have a problem coating it. So that's something you got to keep in mind with steel. Last but not least, PCBs, right? You'll hear about it, ballast, oils. You know, it's a man-made chlorinated chemical, okay? It can be in multiple products. We'll see that. It has a crazy toxicity. It can be thick, it can be light. You know, it's unbelievable the forms we find it in everywhere, right? It was banned in 1978, but, you know, I should have mentioned it. When we talk about these bans, especially like asbestos, you know, that was banned in 1989. Keep in mind, they could have warehouses across the country full of this material already. That ban just states they cannot manufacture it any longer. The ban allows them to sell what they have in their warehouses. So you got to be very careful about that. Here are all the items you can see a PCBs in. You know, transformers were all pretty informed about. We hit a lot of oils when we're done with power plants. We've had many clients say, "Hey, we took the PCBs out of there in 1989. Don't worry about it." Well, we just did a power plant a year ago, and we drained everything. It was all PCBs. So you got to don't take anybody's word for anything. You know, especially when it comes to PCBs and oil. Fluorescent light bulbs. We know about that. You know, the mercury ones, the green tip ones, right? One thing I should say about the green tip ones, you know, everyone thinks they're safe. If you break 6 of those in a pile, you will feel a T-clip for mercury. So that's something to know. Just because there's a green tip doesn't mean it's just throw it in the trash. You know? Cable insulation. We run it a lot in power plants, and we do a lot of work for all the main electrical companies in the country. There are large cable lines going under our streets in every major U.S. city. They get so hot. They send liquid PCBs through the cable to keep it cool. And you see it all the time, especially like the national grid lines, you know, Con Ed, you know, it's a big thing. You know, they've got away with a lot of them, and they're getting better. Going up there is caulking. I think we've all been dealing with caulking for a few years now. Okay, be very confusing on the projects, depending what substrate is, where it is. So when it comes to PCBs, if you believe you have them in a facility, I'll question it. You need to bring a consultant in who's familiar with PCBs, because it's not like asbestos and lead. We have a rule book, right? Regulation for asbestos and lead. There are regulations for PCBs, but they haven't been updated as frequently as they should be. So it depends, you know, what caused it. You know, is it bulk product waste, things like that. So please, if you have PCBs, bring a professional in and let them analyze the situation and advise you how to proceed, because there's many ways to proceed with PCBs. Yes, it can. It leaches. We did a very large project in Boston in which the caulking around the windows leached into the brick. And it wasn't a high percentage, but because it's called an illegal release, illegal use, they made the owner take all the brick out. And it can be very costly. Very costly. And again, it depends on the removal of the brick, what you're going to do with what you're doing with the property. There are different ways that you can coat it, encapsulate it on the exterior, because there's different regulation for the exterior versus interior. That's all I had. I mean, Sean?
Well, thank you everybody for coming, and we hope that that answered questions for you. We have question and answers right now, so if anybody in the audience has anything, I can bring the mic over to you. Unfortunately, the live link does not have a way to ask questions, so it's just anybody that's here.
In working with older buildings, you can suspect that there may be some hazardous materials in there, but sometimes when you've done testing and you know for a fact that there may be materials, what kind of obligations are there to do things about it?
Well, the law says, regulation state, right? And there's no regulation that says you have to remove the asbestos, all right? All lead, unless one, you're going to impact it during renovation or demolition, or it's deteriorated in a form that makes it unsafe. So if you had all justification, if you had a boiler in a basement and that insulation was 100% intact, great. There's not a law that says you have to take that out, you know? Depends. It all depends. It depends caulking versus oils versus leaching. Every PCB issue, I hate to tell you, is totally different. We've been involved with them since 2001, and every single job has been totally different. And it depends where you are in the country too. You know, the EPA regions vary in what they like to see, you know. Like,
asbestos shingling on houses. I assume that's a friable product. Did I hear you say that can be dumped in a landfill?
no, not the asbestos. It's the lead-coated material from a resident can be going to regular landfill.
So if you're stripping a house of asbestos shingles, that's a special requirement to get rid of that material?
Yes, there is. Yeah. Yeah. Yes, there is.
Also on the domestic scale, if we're doing like lead removal of wood boards or lead paint removal from wood boards, besides sandblasting, are there other methods like ready strip kind of paint removal?
I'm not hearing you that well.
Oh, sorry. On a domestic scale, doing like wood lead paint removal from wood substrates, is there something other than sandblasting, like something you find, for instance, at a hardware store, like the ready strip material? Is that acceptable?
There's different chemicals out there, but it all depends what you're going to put on it. You have to double check the chemical you're going to use, because what happens is it will leach into the wood surface and it can affect your paint later on. It could bubble it, things like that. So what I do is, if you want to do a little area, I get a couple of samples of the removal you want to use and just do like 6 to 12 inches and just see which one does the best and what it actually looks like when it's done. But be very careful with it leaching back, you know, bleeding back out after you paint it, you know.
Great. All right. Well, thank you everybody for coming, and enjoy some refreshments afterwards. Thank you.
Thank you.